So welcome everyone to this session, which is labeled Transboundary Cooperation for Improved Data Sharing, Flood and Drought Mitigation, and River Basin Management. This session is organized by 5 UNESCO Category 2 centers under the auspices of UNESCO, together with UNESCO IHP in Paris. So the centers are the International Center for Water Resources and Global Change, based in Koblenz in Germany. It's the IHP Delft Institute for Water Education in Delft in Netherlands. It's the Integrated Water Resources Management Center under the auspices of UNESCO, that is based at the US Army Corps of Engineers. And the US Army Corps of Engineers Institute for Water Resources based in the US. And we also have the International Center for Water Hazard and Risk Management, ICHARM, based in Japan with us. And myself, I'm working at the International Center for Water Cooperation, hosted by CW in Stockholm. So very welcome to this session. And the topic on transboundary cooperation we have chosen because we think it's extremely important. It's been for a long time, but it's getting more and more important as the increase of population put higher and higher pressure on water resources for all different sectors in the society. And as a majority of the river basins in the world are transboundary, there's a huge need for improving the cooperation on water management across boundaries. And in order to do that, one of the most important matters is actually to ensure that data are collected and based on data, information on the resources made and shared between countries to those who are needed. But I will not take much longer time. I will encourage the audience to use the Q&A function to submit questions. We will go through a number of presentations, and in the end of those we will have a discussion. So your questions will be picked up by the moderator, and I will introduce the people as we go forward. So first in line, we have an opening remark to be presented by Dr. Amani Abu, who is the director of the Water Sciences Division at UNESCO in Paris, and also the interim secretary of the Intergovernmental Hydrological Program, IHP. So, Dr. Abu Amani, I will now transfer the speaking possibility to you, and you can go ahead.
Is it okay?
The floor is yours.
Okay, thank you.
Yes,
thank you,
thank
Matt.
you.
Thank you, Matt, for the introduction, and also thank you for the opportunity to make a few remarks at the beginning of this very, very important session. First of all, I would like to welcome you all, of course, to this session, and to congratulate the 5 category centers for joining together with the Secretariat to organize this very, very important session on the importance of cooperation within river basin for addressing climate risk and water management at the basin level. As we all know, within the last report issued by World Water Assessment Program, so within the CWW2020, which was on water and climate change, it was clearly identified that around 74% of all natural hazard between 2001 and 2018 were water related. So this is very important to keep in mind. Second, still within that report, during the same period, past over 20 years, a total number of deaths vis-a-vis the issue of flood and drought was exceeding 166,000 people. And also in the same period, around 3 billion people were affected by flood and drought. So this is really huge if you put it in context of impact and economy and so on. So this is why the issue of meeting the challenges associated to water-related disasters at the river basin, particularly Transboundary River Basin, requires some key issues. The first one is extremely important to put in place a disaster risk reduction strategy within the basin at the basin's level. Second, it's important, as Matt alluded initially, the monitoring system and exchanges of data is crucial among member states sharing the basin. And it's also important to look at all the management of societal needs across borders. So those are some key issues which has to be addressed within the level of basins if you want to address the issue of climate risk and water-related challenges within river basins. So cooperation is crucial for that. Indeed, at this scale, we know that water is connecting countries because of the transboundary natures of the basins. Water is connecting the sectors. We know that many sectors needed water, energy, food, environment. We know that also water is connecting stakeholders and also water is connecting people. So cooperation is the core, is the center of issues when it comes to transboundary river basins. On top of that, also, we need to keep in mind also the fact that water also is connecting international agendas. Among us, we have the Agenda 2030 with the 16 SDGs, and we know the key role of water for that in achieving SDGs. We have the Paris Agreement, and we cannot believe to have climate resilience if you cannot address the water challenges issue. Also, the Sendai Framework, where we know that 90% of natural hazard disasters are water related. So this is really putting the framework of the critical importance of water in addressing those challenges. So as you know, UNESCO, through its different programs, have been promoting cooperation. All our scientific program is about cooperation. But I want to flag one of the program which is dedicated specifically to promoting water cooperation among European countries and stakeholders. This initiative is called the PCCP, as we all know, from potential conflict to cooperative potential. And this program, as you know, was launched in 2000, which is working on the transboundary, how to work to promote dialogue, and with ultimate objective of having peaceful management of the water resources within river basins. And we strongly believe that water is a catalyst for cooperation. Within this session, because this session is very specific to related to climate change and disaster issues. So within this session, we'll have case studies which will be presented by the different 5 Category 2 centers of UNESCO. And those case studies are generally related to UNESCO's initiatives such as the International Flood Initiative, the International Drought Initiative, and also the GWD program, we all know, which is dealing with arid lands. So in ending, I would like once again really to thank and to congratulate this very important cooperation. This is really the way forward now for IHP. We want to bring together within a similar team members of the family so that they can work together, they can cooperate, move forward knowledge, capacity, and also disseminate collectively. So I want to thank again the team within the secretariat led by Anil Mishra, and also really of course all the participants, because without participants we cannot have a session. So thank you very much. Back to you, Matt.
Thank you very much, Dr. Ramani. That was a very nice introduction to the program. And without further delay, I will then give the floor to Mr. Harald Kote, who is the Director of the International Center for Water Resources and Global Change under the auspices of UNESCO and based in Koblenz in Germany. And Harald will introduce us to the importance of data availability and sharing on river basin scale for mitigation of floods and droughts. So Harald, you should now be able to share your screen and to take us through your presentation.
Okay, thank you very much, dear ladies and gentlemen. Thank you, Abu Amani, for this introduction. The title of my presentation is The Importance of Data Availability and Sharing on a River Basin Scale for Mitigation of Floods and Droughts. And you see here, I'm together with a team of several global water data centers, and they are all behind this presentation. As already said,
Yes? We cannot see your presentation. I think you need to share your screen.
I did.
With the PowerPoint.
Let me see. I did it.
We can see you very well, which is of course very nice.
Okay, but yeah, I tried to share. I share again. Sorry. Share. Now?
It's coming now. Yes, now you're on the screen. If you can just
sorry.
slideshow mode, that would be great. Thank you, and please carry on.
Okay, I'm sorry. So, but you already have heard me, so I can skip the first, let's say, slide. You see here all the teams behind me, the global water data centers, which are located in Germany. These are 3 of us, and we are acting under the umbrella of the UNESCO IHB, but we are all connected also to the WMO and to UNEP, to other water programs. So why are data so important, and especially hydrological data? I took here a figure from a very recent report from UNDRR, and I only want to highlight, you see here, a scheme of how disasters are important. And you see the overall damage is more to storm, but flood is already on the 2nd position, and drought on the 4th. But if you focus with the figure below on the people who are affected by this disaster type, you see that flood and droughts are the most severe disasters. So this, I think, is a reason enough to know a lot about water cycle and how floods and droughts are occurring. And even more, I was astonished to see from this very recent report from the WMO, who analyzed data over several decades, how severe various reasons or sources for hazards are. And you see here floods are in Africa also very, very important. And from this report from the WMO, who is from 2020 and gives the importance about to improve early warning systems worldwide. They have a strategy with 6 recommendations, and you see number 5 and 6 is develop more consistency in monitoring and evaluation, and 6 fill the data gaps. And this is important, how to fill the data gaps. And as you all know, we are improving a lot with remote sensing data, but I want to focus very much also on in situ observations. They are essential as well. And you see here that the WMO, for example, is coming up with a new data policy and has in previous resolution already pointed to that the data exchange of today is essential and crucial, and especially then for transboundary use. And you see the driver for change is, of course, we have the explosive growth in societal demand, and to have more information about weather, climate, and hydrology. And hydrological in situ observations are necessary because we need them as basic data, and for ground truthing as missing counterparts for Earth observations. And I would say if we could get permanent monitoring data, that would be fine. But even if they would near or even real time in the future, that would be ideal. But this is a very high, let's say, demand. And UNESCO IHP is also pointing out how important data are. The 9th phase is in progress, as you know, and I have 2 basic steps here, which are draft ready. Improving the quality and quantity of water data by enabling an increase in the density of collection stations and better validation of such data, and then enabling data accessibility and visibility, comparable and usable data series, and open access data. So this is the basic need. And what we see here is where are such infrastructures are already existing, for example, to serve for global water data. And you see here a scheme which comes from the Global Terrestrial Network of Hydrology, which is hosted in our center. And you see here in this scheme all the existing operational global water data centers, and each of them is concentrating on one of the essential water variables, and altogether they make a good picture of the water cycle globally and then regionally, and of course downscaled also locally. And what I want to highlight here is on 3 centers at the moment, which are in Germany. This is the Global Precipitation Center. You see these red lined, and the Global River Discharge Center, and on the left side down, you see the quality data from the GEMS water data, which is hosted under the umbrella of UNEP. And now from those centers, I have some pictures looking into the Nile catchment. You see here from the Global Precipitation Data and Climatology Data Center, you see here all these yellow dots are precipitation stations in the Nile catchment. And this looks quite good. But if you look deeper into it, it counts, do we have permanent information from all these stations? And there the figures changes. Also, I want to highlight a little bit the left graph on the left side. And here you see the development of getting data over the decades, starting from the beginning of the 20th century. And you see there is a very well increase, but nowadays I think we have reached a peak. And then, of course, there is a slowdown of that. One reason is, of course, that the data are coming in up to 5 years later into this global database. So this is one reason. But on the other hand, there is also a little trend that we're getting less data. And if we look, for example, in the global runoff data center, how is the situation here in Africa? And you see here also a lot of stations, 1,585 stations. But you see here also we are looking to the time series. And if you look into the world map, you see here how the time series are available, and you see that the red dots and the yellow dots are stations where we are lacking information over decades already even. So all these global data centers are already acting for 3 or 4 decades even. And what can they do? These variables can put together to a product. And here you see a product, a very recent product from the precipitation and the runoff center for the Nile. You see here the water flux, the freshwater flux from the Nile over the time into the Mediterranean Sea. And as you see here, there is, starting from the 70s, a large decrease of the discharge, and you can all imagine that it has something to do with the Aswan Dam. But you already see the blue line is a very recent result from 2019 with the global water model water gap. And the green line is from 2014. And what you also see here on the left side down is the data end, for example, of stations in the various countries in the Nile catchment. And you see we are lacking a lot of recent data. So that is a little bit compensated by the modeling with water gap, but it is not a very good situation. And if we look further to the water quality, the third center, you see here also what is available globally, and also therefore accessible for everyone is quite a poor, let's say, a poor situation. You see some countries have never provided quality data. And what we would like to have is, of course, to measure the loads together with the water fluxes, the contaminant loads, and to give good advice to decision maker how to decrease, let's say, maybe pollutant loads in the Nile. But what we need is, of course, a transboundary collection in the catchment to understand the system and to know how to improve the situation. So coming to some key messages and to conclude my presentation, some key messages for take home. The global terrestrial network and the global water data centers offer an infrastructure and service for global and transboundary data collection and product provision and exchange. But common standards for metadata and exchange formats facilitate the interaction for all. And therefore we have to agree on metadata formats. Thirdly, the data provision from constant in situ monitoring of essential hydrological variables is still poor or lacking from many countries. Consequently, the international and transboundary exchange of hydrological data is poor with many gaps. On the other hand, as you have seen in the Southern Hemisphere, disasters are dominated by hydrological events, droughts and floods. Without reliable, continuous and in situ and remote sensing data with common standards, prevention tools cannot use the understanding for the system and the scientific technical consultation for decision maker. The observation from data acquisition for many countries is keep national data or regional hydrological data secret or use them commercially. This makes the necessary common system understanding in transboundary catchment for prevention measures for human and nature welfare impossible. And effective prevention and adaptation measures and warning system depend on both system knowledge through availability of permanent monitoring data and scientific advance. And finally, it would be wise and economic to spend more money and resources and efforts in common water data fundaments to reduce the enormous costs of disasters and amount of killed people. Thank you very much for your attention.
Thank you very much, Harald, for that really nice presentation. And I really like the last comment there, that there's a huge cost of not measuring the water resources in terms of loss of lives and livelihoods and so on. I refer to the International High-Level Panel on Water, who described that what you don't measure, you cannot manage. And I think it's rather important and true. So now we will move from Germany to the Netherlands. And I will invite Eddie Morse, who's director of IHE Delft, and Saki Schuber, who is an expert and a lecturer in law and water diplomacy at the IHE Delft Institute. And I will now see if I can change the ability to present to Eddie and Saki. So now you should be able to speak and share your screen. And so Saki Schuber and Eddie Morse will then talk about frameworks and constraints on sharing hydrometeorological data and information in a transboundary context. Please, Eddie and Saki, the floor is yours.
Thank you. Mats, I hope you can already see the presentation.
We can see and hear you. Thank you.
Thank you. Also, thank you very much for the nice introduction. I would like to also stress that we slightly changed the title of the presentation, and that has to do with the fact that we do think that if you want to go for sharing data, a very important basic foundation for that is having an agreement between one another about the sharing, but also having frameworks in place. And we think that there are some quite nice examples already on the board, and maybe we can learn actually from those examples. And that's where Saki would like to present something about, and we hope that we also have some points for discussion that may initiate further thinking, also from the participants about how we can make a step forward. I would like to give the floor to Saki.
Thank you very much, Eddie. So let's get started. What we'd like to do over the next few minutes is to present and say a few words about hydrometeorological data and information as well, the kinds of frameworks that are already in place for data exchanges. And we talk about frameworks thinking beyond those existing or relating to water and transboundary water management, but picking up on some of those that were already mentioned by previous speakers. We'll say a few things also about the challenges that are being faced when it comes to data exchange, opportunities as well, some key messages, and as Eddie just mentioned, a few points that we hope to be able to discuss with the other panelists and with the audience. So why do we need data in the context of transboundary basins? Well, very generally, water resources management requires data for planning, operational management, and monitoring purposes. So data is very much present, very much part of those efforts to manage water. An important point, I think, to note here, we're talking about transboundary data, but it's also very important to think about intrastate sharing of data. When we look at it from an international perspective or an interstate perspective, it seems obvious that there's a homogeneous, or it seems logical that there might be a homogeneous source of information, but that's not always the case actually. And of course, the exchange of data and monitoring is extremely important when it comes to operationalizing cooperation on the ground when it comes to an international water body. So what kind of data? This presentation is entitled Hydrometeorological Data and Information. So when we think about hydrology, we think generally about blue water and quantity, so river flows, surface water abstraction, groundwater levels, and so forth, as well as issues of quality. We've got meteorological here, so precipitation, wind, humidity, snow depths, temperature, some of the data that we might draw from meteorology, difficult to pronounce. But let's not forget other types of data that are also important and relevant in that context. Economic and social statistics. We had a comment earlier about societal needs, and those might be reflected through that type of data. Of course, most countries have statistics agencies that will be looking at that data and providing that data, gathering that data, and how that data is exchanged domestically is also important. We have other bodies also collecting statistics like the FAO and others. So I mentioned earlier different frameworks for data exchange, and on the slide you can see a list of those from which the frameworks we're going to talk about in this presentation are drawn. So Agenda 2030, SDG 6, of course, and there's a drive for data, as I'll mention in a moment. We have water, of course, and international water law has a very important role to play as an umbrella or an overarching perspective on the exchange of data. Meteorology, disaster risk reduction, as we had from the previous presentation, is extremely important as well, given the cost and potential losses. And of course, we talk about climate data, so climate change is one of the frameworks or one of the sectors from which we draw certain frameworks. Now, 2020, when it comes to SDG 6, has been a year in which data has been the center of attention. We have the UN Water Integrated Monitoring Initiative for SDG 6. Now, of course, this is not data between riparians that is being gathered and collected, but it is an effort to gather data, and data that is relevant for SDG 6 and the different indicators, of course, but the efforts that are being undertaken within that context are also relevant within other contexts and in the context of transboundary cooperation as well. So it's noteworthy to mention this particular framework that is also requiring data to be provided. Now, water and international water law has an extremely important role to play. And on this slide, you can see different levels at which there are requirements for riparian states to exchange data and information. There's a customary obligation of exchange of data and information. So for those of you who are not so familiar with international water law, customary international water law applies to states beyond treaties. It's not embedded in treaties, but it's considered to be applicable to all states. And we see that hydrological data here, but also data about plan measures, information about proposed activities on transboundary basins is required to be exchanged between states. We have two global framework conventions, the 1997 Convention and the 1992 Convention, in which we also find provisions requiring states to exchange data. So for those states that are bound by these two treaties, there are specific obligations, and it should be pointed here that the 1992 Convention has quite a broad range of areas about which information and data should be shared. And we see also regional requirements here in Europe. The European Framework Directive, Water Framework Directive, and the Flood Directive also contain similar provisions for the exchange of data, and we have some principles as well. Basin treaties, of course, some basin treaties contain very comprehensive frameworks for the exchange of information, and that will be one important level at which one would hope to see the operationalization of exchange of data, because that particular type of agreement will be specific to basins, and riparian states can agree the type of data to be exchanged and how to exchange it. Now, international water law is about water resources management generally, but an important part also of the data that we're talking about today is meteorological data. And here we see that the WMO has a number of regulations in place for the recommendation of for the exchange of that kind of data. And so there is a framework in place within the organization already, and a push there also to facilitate that exchange. And in the coming weeks, there will be a data conference online, which will focus on the exchange of data and the support of SDGs through the exchange of data. So another sector that has those requirements. We've heard about disaster risk reduction, and there also we see in the Sendai framework some requirements relating to the exchange of data and information, in particular to enhance disaster preparedness, but for other purposes as well. And climate change, finally, within the UNFCCC, we see also that the exchange of data and climate information is one of the aspects covered by that. So what we're seeing is data and the exchange of data, the production and exchange of data as an issue of concern within different frameworks, within different sectors, and all relevant to what we're talking about. So pushes from different directions. Now, having appreciated now that there are a number of frameworks in place that should help states exchange data, that's only the beginning. We see that there are a number of challenges. Recently, the UNECE Convention Secretariat held a workshop on this very issue. And you can see here the kinds of challenges that were reported within that workshop and reported in the paper mentioned, whether it's issue of harmonization, the provision of timely and accurate data, institutionalizing the exchange, or financing the provision and exchange of data. This is what was highlighted within that paper. But we see also other issues occurring. So data has to be produced, and there is a cost for that production domestically when it comes to different agencies providing that data, with the requirement at times to pay for data. So even intrastate exchanges may be costly and may be an obstacle to that exchange happening. The private sector is involved also, which raises issues also from a contractual perspective and from a cost perspective. There are different frameworks, as we've just seen, for data exchange, which are not necessarily streamlined. And very often, although I mentioned the importance of basin treaties, there is often a lack of a specific legal or institutional framework for organizing and sharing the data. Now, we also see opportunities, and we've heard already about the many international databases and initiatives that provide data. And we see also that technology is playing an important role, and that will be something that we hope to discuss again with open access through GIS. Citizen science also, the possibility of citizens gathering data and sharing that data as well. The availability today of drones that can cross borders quite easily and have a high-level perspective. So there are a number of ways in which data can be obtained beyond the frameworks mentioned. So some of our key messages: we see the availability of these open data sets, which we hope will facilitate the exchange of data as required under the different frameworks mentioned. We see new ways in which data can be obtained, whether through citizen observatories or other ways. We talk about the exchange of data, but the quality of the data itself is also key, and that is something that needs to be taken into account. Data needs to be shared both nationally, intrastate, and internationally. And then a point perhaps to mention as well is that bringing together, combining different data sets is also a way of increasing the value of that data. So perhaps not looking at specific types of data in silo, but bringing that together is also something that could be encouraged and done more. And we see also in terms of cooperation around data sharing, that other sectors rely on that. For instance, international air navigation, and that's a sector where it's happening relatively smoothly. So I'm going to end on some additional discussion points that we want to share with you and encourage you to reflect on. The availability of other types of data, remote sensing, proxy sensing through drones, and citizen data, which provide new sources of data, but also raise some questions. The adequacy of the setup of frameworks, which decision makers do not necessarily rely on in the best possible way. And then a general issue, the use of data also by non-water ministries and other agencies. I think water is important to areas such as health, energy, and agriculture, of course, and the ability to use water data for those ministries and the ability for them to make informed decisions is also key. So on this note, I'd like to thank you all for your attention.
Thank you very much, Eddie and Saki, for that thorough presentation of all the frameworks that help us to determine how data can be shared and so on. There are a lot of challenges between these lines. I can see that. Now I will quickly hand over the floor to Dr. William Logan, who is the director of the International Center for Integrated Water Source Management in the United States. So, Will, please go on. The floor is yours.
Excellent. Can you hear me?
Yes, thank you.
Okay. Great. Well, this has been a wonderful session so far. I hope I can continue it in a wonderful way. The overall theme, of course, being transboundary cooperation, and we're seeing that through UNESCO IHP programs and centers, one can work multilaterally, building confidence. And the point of my talk will be, I will be showing some tools developed through UNESCO's Arid Regions Program, GWADI, some of which are top-down, some of which are bottom-up, and these can be combined with things like the data sets that Dr. Kutis spoke of and citizen science that Dr. Schuber talked about, all while working together with the International Hydrological Program. And so just briefly, the UNESCO program that I've worked most closely with, it's called GWADI, and it's the Arid Regions Drylands program of UNESCO. And it has not just global networks, but it has regional networks as well. And you see here Arab networks, a Sub-Saharan network, and the Asian GWADI network. So the networks are a key place where cooperation can happen. And I think I'll just skip this, except to say that there are these various centers and university chairs and UNESCO offices around, lots of people to help countries who are interested in transboundary cooperation on their watersheds. So very briefly, I'm going to cycle through just some examples of tools that the GWADI has developed. One of which is a Drought Atlas. The Drought Atlas it's a statistical tool. It's for drought frequency, can be used for flood frequency. And this was done especially in Latin America. And it can be done either on an individual country basis, or it can be done on a continental or regional or sub-regional basis. So this is these kinds of projects. You can see that pretty much every country in Latin America and the Caribbean participated in this project, and those networks, those projects, help to build confidence for countries who may be willing to work together on a bilateral or multilateral basis in their river basin management. A similar kind of statistical project for Latin America, for Central America, with an emphasis on again on the midsummer drought, which is a common phenomenon faced by all of these countries. Another product that we worked very closely with is the University of California, Irvine's iRain product. And this is a real-time product. It's an estimation of rainfall, either in the last 3 hours or 24 hours or 72 hours. It's an estimate, like all of these products, but it's very close to real time, often less than 1 hour old satellite information converted to these estimates. So this is something, this is the top-down part of the tools, looking at in this case, Africa from space. And of course, this can be done at a country level or a regional level. And so this is the Namibia's daily flood bulletin during their flood season. And so they put these out there, and they're used by hundreds of people, especially those who are working in eastern Namibia, in tourism, in wildlife, in agriculture. So it's a very useful tool. You can see that in this case, it could be used for the Zambezi River or the Okavango River, for lots of different possibilities there. Here's a historical version, similar tool. So you can look at the changes in rainfall over the last about 36 years. And I won't get into all the details here, but the statistically significant trends do not have those diagonal lines or hatchers. So if you're in Niger and interested in seeing what's been happening in Mali upstream on the Niger River, you can see that rainfall's been increasing. And if you're in Jordan, on the other hand, and hoping Saudi Arabia will be getting more recharge of their aquifers in the future, the trend is definitely in the wrong direction there. So these are just examples, again, two graphs of yearly trends in Mali going up, in central Saudi Arabia going down, both statistically significant. Another tool we've used a lot are the flood and drought monitors out of Princeton University, currently being updated and will be operational again soon. But these are land surface models, and so you see a variety of products. Again, you can think of this as top-down, precipitation-driven tools. And so countries interested in working together, they can use these kinds of tools. You can calibrate those tools. For example, on a country basis, you see here Chile, Zimbabwe, or regionally for the Lake Chad Basin. And so there are ways then to use these tools and hopefully calibrated with the kinds of data sets that Dr. Kutte spoke about a few minutes ago. These various surface water and rainfall and water quality, other kinds of data sets. So we can combine these kinds of models, and a similar model that you'll see more of in a minute with Professor Koike's work in Western Africa. These can all be put together for countries and regions who are interested in improving their transboundary cooperation. Then the last point I'd like to make then is we've talked about satellite products, we've talked about surface data sets, we've talked about Professor Dr. Schuber talked about citizen science and stakeholder engagement. All of these things can be done in a UNESCO IHP network with centers, with the regional UNESCO offices. And this last slide here shows a water management framework that UNESCO helped to develop and is helping to promote with its partners, called CRIDA, Climate Risk Informed Decision Analysis. And it's a way, along with stakeholders, to work at a local level, at a country level, on water management issues. So with that, I'll share my screen back with the organizers and move on to the next speaker.
Thank you very much, Dr. Will Logan, for that nicely illustrated presentation. I think you exemplified beautifully how we in the 21st century can use remote sensing for capturing data and GIS for displaying it, and IT solutions to communicate them. So I think that is the important assurance tools of these days that we need to take advantage of. Now I will quickly turn into introducing the last presentation and the last speaker in this line, and that's Professor Toshio Koike. And he is the Executive Director of the International Center for Water Hazard and Risk Management in Japan. And Professor Koike will talk to us about a presentation labeled Towards a Regional Flood and Drought Management Program in Africa. Please, Toshio, the floor is yours.
Thank you very much, Matt. And I'm very happy to join this the UNESCO Category 2 Centers and the UNESCO IHP collaborative session. For the regional flood and drought management program in Africa, this is very important under the current climate change condition. This figure shows the spatial distribution of water-related disaster in Africa in the past 16 years from 1980 to 1995, which includes meteorological events such as cyclone by green circle, by blue circle, and the climatological event such as drought and heat waves by orange color. And in recent 16 years, from 2000 to 2015, you can identify the change. Okay, so see a big increase in the number of hydrological events, such as flood, all over the Africa. From the statistics of the water-related disaster in the whole of the Africa, the number of events and the overall economic losses, you can see number of events and economic losses increasing considerably, especially the increase in rate of these two statistics of hydrological event flood are more apparent than the other event. So thanks to the fifth assessment report of the IPCC, we can get projected changes in precipitation following the representative concentration pathway RCP over the regional land monsoon domain of North Africa monsoon by using these three indices. Let's look at the R5D, a seasonal maximum precipitation in total, CDD, the seasonal maximum consecutive dry days, which are related to the flood and drought. You can identify these indices are projected to increase. Furthermore, PSD, standard deviation of interannual variability in seasonal average precipitation, is also projected to increase. This is closely related to the water resources management. And the multi-model ensemble the third and fifth couple model intercomparison project, CMIP3 and CMIP5, so you can identify the changes of the heavier rainfall in Central Africa. So, responding to these changes, the West African country people got together in cooperation with the UNESCO and also the regional center agreement and the Volta River Basin Authority, Niger River Basin Authority, and ICHAN, they develop the water disaster platform to enhance climate resilience in Africa, WADIR Africa, with financial support of the government of Japan. And we launched our project June last year. And under this COVID-19 condition, we continue to implement our project. Early system based on the hydrological understanding in this area, and we develop prediction models, and also only by available data set we real-time flood monitoring early warning system to be used for operational purposes by the 11 countries. So the hourly real-time rainfall from the product, satellite product after the so is available in operational way, and the flood discharge, river discharge is monitored in real-time basis. And in this case is Volta River cases, river basin case. We identify the hotspot area in Sansani Mango in Togo, in a branch of the Volta River. And we apply the final spatial resolution model, RRI, to estimate inundation in a local scale. And this data is overlaid with Sansani Mango city information by GIS. And this is used for development of the hazard map and also the contingency plan. So the duration and peak of the flood, the depth and area is monitored by this GIS system coupled with the local the flood model. And based on that, the information in cooperation with various stakeholders, so emergency response, each related organization can be described in the past. Originally, these the systems are introduced, and also the capacity building program would be help in the field. But under this COVID-19 condition, we cannot be implement. So then we developed the e-learning course for the capacity building of the local people, and we did the first the e-learning. These material are available in English and French both, and the 3 lectures and 4 tutorials are implemented now the first week of the September, and totally the 48 participants joined, and we have the self-evaluation test. So 26 of the 48 participants have passed the self-evaluation test. So we will have another 3 opportunity for this the e-learning course, and totally 300 participants will join. So in this way, we developed the flood, the resilience, the cooperative framework with West African countries and UNESCO and ICHAM. So with regard to the drought, I'm a remote science person, and we developed the soil moisture product, and my algorithm is used as a standard algorithm for the global soil moisture product operationally. And also we developed a land surface data assimilation system for the soil moisture. However, this satellite product and land data assimilation system can cover only surface water. So, but we also combine the dynamic vegetation model with this hydrological system, and this dynamic vegetation model calculate the water in vegetation. So satellite can identify the standing and lying water in soil. So then we can see the root zone of the water by combining this system, not only the surface water, but by using this root zone water as an initial condition of the drought prediction, is very, very effective. So we applied this system to North Africa. And this is a national wheat production in Morocco, Algeria, and Tunisia. And in 2007, Morocco suffered serious damage from the agricultural drought. And our system applied in Northern Africa. And we implement the 3 months prediction starting on January 1st to the end of the March. And in Morocco and Algeria and Nigeria and Tunisia, we have a very good prediction of the agricultural drought. We also applied this system to Somalia, and in this case, the 1.5 year prediction of the agricultural drought, which applied and validated in case of the serious drought in 2010 and 2011. So this is our scientific capability which can be applied to Africa. Thank you very much for your attention.
Thank you very much, Professor Koike. Now we've had 4 very rich presentations, and we will now move into the discussion, and I will encourage any participants out there in the audience to submit your questions or comments or any kind of inputs via the Q&A session. At the same time, I will then hand over the floor to Dr. Anil Mishra. Anil is a very experienced water scientist, and he's the program specialist at UNESCO IHP in Paris. So Anil, I let you take us through the discussion, and we'll spend about 22 minutes until 4 o'clock with the interaction between the panelists and any questions that might come from the audience. Anil, please.
Thank you, Matt, and thank you all the panelists for excellent talk. Indeed, we covered from the data framework, data availability, the possibility to have global data centers, and including the tools and methodologies. So I would like to ask the audience to come forward and put their question in the Q&A in your screen, so that we can, if you have a specific question to the panelists, we can go. But while we are waiting for the question, I thought one question based on the presentation from Herald or from IHE, from Will Logan and Toshio Koike, that how it is possible, because we are talking about data problem and the declining of in situ measurement, and also at the same time there are low-cost sensors available and 3D printers available. How it is possible to use citizen science to get some of those data at the local level, so that we can test and validate maybe the product that Will Logan showed, like from the CHRS. Is there such possibility to use low-cost sensor using also non-scientist citizens to involve them in scientific processes? So maybe I would like to ask question with Herald. Any thought? At the same time, I would like to ask audience to come forward with the question. Herald.
Okay, I can. Do you hear me?
Yes, I do.
Okay. Yes, I think citizen science is a new development with our changing society and communication possibilities. But I would like to emphasize at first, anyhow, what we are taking as a new sophisticated technology. We need some let's say, a minimum of in situ installation of measurements for the hydrological variables. So if we are not able to make a ground truthing with the technologies we are using, whether is it this citizen science or is it remote sensing, we are limited to, let's say, calibrate and to make a true thing of these results. And as you have seen here, I think for me, this at first, and so we are concentrating with all our data acquisition since decades. We experience a lot of different behaviors. Why data is not shared, why data is not harmonized on the meta level to exchange. I think this is a fundamental lack. So I think we should really consider that whether what we develop with science in the future, I think we need the basic instrumentation still. To what extent ever, that has to be combined with the new technology. But maybe some other colleague will like to elaborate more on the citizen science, but I'm very much concentrating on this fundamental part, because I don't see any real progress if we are not able to make a ground truthing. Thank you.
Thank you, Harald. I would like to go to, yes, I see Eddie. I will come back to you on that. Okay, go ahead.
Yes, thank you very much, Neil. I just wanted to support Harold in the way that I think that good data are, I think, of essence, especially for ground truthing and verification. I do think that there is a strength in things like citizen science and low-cost sensors, as you mentioned as well. One is the spatial extent. I think that's much bigger than we can ever achieve with quite expensive setups that you need for good quality data. But another, I think, very positive element to that is that you get a better commitment and a better understanding and awareness of the citizens about difficult topics, and also about certain decisions that you would like to make. And then a problem there, and that's why we are also interested in that, is about how can you, in a court case, say defend a case based on citizen science data compared to real data. That's quite difficult. So I think there's a challenge also for us to look how we can use those data that are of lesser quality still to make informed and supportive decisions. So I think for decision makers, there is a challenge to find out how they can use the data without running the risk to come into a court case where they can't use the data to support their decision.
Thank you very much. I want to go to Toshio Koike. We all are facing problem, and from the slide that Harald showed, and also from the IHE, I think the declination of data, particularly in Africa, in Nile Basin, within that context, and you are facing this problem also in Volta Basin or Niger Basin. What do you see? How do you see possibility of using these 3D printer, local weather stations or low-cost sensor to provide at least some ground data to validate your local hotspot in Sansanimango, for instance? Would you be able to use some of those low-cost sensor or 3D printer weather station to compensate some of the local data that you are looking for?
Okay. Firstly, I would also echo the and Harold. From the standpoint of the remote sensing and numerical model or climate change assessment, in future, long-term quality data is very important. This is essential. Even the number is limited, but such data is essential. to get those data or share the data, our science group need to show the benefit to be shared among all large community by combining such a issue to data with model satellite data or climate change analysis system provide a beneficial result to society. That the understanding can promote the data sharing. So that is one point. And to respond to your Anil, your question, we also need very local data for the disaster damage and how to reduce the risk. So for that purpose, you mentioned the so-called citizen science data collection or data ownership by the people is very, very important. As such kind of the community, that makes the society very resilient against disaster. So that is my understanding.
Yeah, I think now we are off the track, and Dr. Jackie Schubert showed us SDG synthesis report. The community is off the track on meeting SDG target 6. I will come back to you on that, but I think there is a follow-up question to Toshio. Based on your presentation, probably, if you can quickly respond to the question that I received from chat box, how much is the accuracy and time span of forecasting? I guess this question is based on your presentation.
Okay, with regard to the maybe this question to my long-term prediction of the drought, maybe agricultural drought.
I guess so.
Drought, the prediction accuracy was considered as a very strong dependency of the seasonal rainfall prediction. This is true. Our science community have not enough the seasonal rainfall prediction capability. But to compensate the gap, as I introduced, our system can monitor the root zone soil moisture. If root zone soil moisture exists enough, even the rainfall is very little, very less than the normal, the vegetation grows up. If the root zone soil moisture is very, very low, if rainfall happens, the vegetation cannot grow up. So by monitoring the root zone soil moisture, which cannot be observed in past in the large scale, but such kind of the capability can improve the accuracy of the prediction of the agricultural drought. So actual accuracy, of course, depends on the prediction of the long-term rainfall. But the scientific effort can improve the accuracy of the agricultural drought.
Okay, I see there is a question from Nigeria. Seems to be facing lots of challenges with regard to data. Probably how can individual access data and the data can be applied in Nigeria. Will, you talk about top-down and bottom-up approaches. And top-down approach, you mentioned about some of those global models using satellite-based remote sensing data, precipitation, even applied to provide forecast for the Namibians' poultry or tourism. And you also mentioned the bottom-up approach. How can individual access to those data, and if that can be applied elsewhere, like in Nigeria? Will?
Yes. So data access is for the satellite data is actually pretty straightforward. If you just Google CHRS, which is Center for Hydrometeorology and Remote Sensing, UC, University of California, Irvine, you'll find a website where it's easy to look at and to download data. Right now, the data on the African Flood and Drought Monitor and some similar monitors, that site is down, but we hope in a month or so that will be up. And if you just Google at that point, African Flood and Drought Monitor, Princeton University, that's an easy one to get at. So that and some of the other data sets are a little more difficult, but the NASA and European data sets, but they're all trying to make them easier and easier to download. At the bottom-up level, we are developing an online course. I know Anil knows about this, that on this CRIDA, or Climate Risk Informed Decision Analysis, for and that's that will be something a self learning course that people can take, and in my mind, the bottom up and the top down work together. You need data. You need to understand, have some understanding of future conditions, but you start with present conditions. But then you also have to combine it with the local stakeholders or the country stakeholders. So that's not a very good answer, but that's my answer.
Thank you very much. We have a very limited time. I will read a couple of questions, but those questions are already answered. But I just want to mention that there are different technology available, but if people do not trust, they do not want to share, and that's why we are talking about ownership, including with the local stakeholder, engaging citizens in data collection method. For seeds, it's similar as Will mentioned, as Toshio mentioned, you can download data from the global website. Herald, I would like to come back to you, but I just want to raise one important point with IHE, since they mentioned about framework, and we are off the track on SDG framework, particularly on meeting SDG goal, and transboundary cooperation being the title of this session. So Eddie or Jackie, what is your view that we are off the track and we are still talking about same issues, that data is not sharing, whereas there are different methodologies and technologies available. And there is a now new coalition global accelerator framework for SDG from IHE, which produces human resources to contribute to meet those goals. Very briefly, if you can highlight.
So if I understood your question correctly, the question is about how to improve the provision of data, particularly under
data provision of data and data sharing. And we are showing same slide, from 80s and 19. There is we don't have data sharing, and we are talking about off the track. We are talking about accelerator framework. What is your take on that?
I think it shows that it continues to be a challenge. I think probably for practical reasons. As I said earlier, data sharing intrastate between different agencies, between different ministries, we know that it can be challenging. It can be difficult to achieve at that level, which makes it even more challenging sometimes to share that internationally. I think it's there isn't one answer to that, but continuing to highlight the benefits and highlighting where information can be found beyond a particular country, relying on different data sets. and highlighting the existence of those data sets to facilitate that sharing, I think will need to continue. And I think we have an additional comment here.
Because I think it's a quite a good question, Anil, and I think it's, although I think we all appreciate and I think we all would support the official data collection, it's a difficult task to increase that. So we're seeing a hurdle there. I think that with the better use of citizens and informal data, like citizen science, but maybe also remote sensing or proxy sensing, maybe we can make this leap. But that require another way of thinking and not giving up on the official data, because I fully agree we need that. But I think if we really want to make an acceleration and a step forward, maybe you should pay a little bit more attention to the unofficial data and how we can use them officially.
Thank you, Eddie. Herald, if you can summarize your statement in 1 minute, then I will ask Matt to summarize the panel because we have a very little time.
Yeah.
Herald.
Yeah, thank you. So I want to still highlight the global data centers provide all their data free for access for everyone in the world. So that is available online, continuous. That is one part. The other part I want to say is, I think to make it more attractive to share data, we need examples about products from those data and how those products are attractive for decision makers. So that is a very big incentive, to my opinion, and we have a lot of knowledge altogether, and there are fantastic models and model chains available, but I think it needs still education, and it needs, let's say, improvement in implementation on a regional and local scale, and therefore I plea for good case studies with global available data to see that it is a big value to provide the data. Thank you.
Thank you very much, and thank you all the panelists for your presentation and your responses to the question. I will hand over back to Matt to summarize and close the session. Matt.
Thank you very much, Dr. Anil. Thank you for that excellent moderating skills that you provided in this panel. And thanks to all the panelists for beautiful presentations. I think this session has been extremely rich. And each and every one of us, I think we will take different messages home maybe. But I'll just share the things that I noted down, which I think is worth mentioning. And I have 5 points here. My first one is, even in the 21st century, the world is taking a huge toll in terms of lives, livelihoods, infrastructure loss, etc., from floods and droughts. So we really need to gear up to deal with this. We cannot continue losing lives and livelihoods in the way we are doing at the moment. Second, we need to improve the network on the ground as well to support the improving status of remote sensing facilities. And this is really sad to see the statistics on how we lose measuring stations around the world. And I think it's really important to keep long series continuing so that we have the historical record to build on when we try to make emphasis on what's happening in the future, on scenarios and so on. So ground truthing, very important. Third one, citizen science. How can we use the enormous amount of human resources around the world to actually improve knowledge about the resources, and not the least the commitment, the awareness, and the ownership that also comes with that kind of way of getting data on board. I think that's an interesting avenue forward. My fourth point is, we really need to stress the cost of not measuring, the cost of not sharing data. I'd like to pledge to the decision makers and politicians who think that they are saving something by hiding data or keeping them secret, while we could actually gain so much by being more open and transparent in what we do and share things for the best of everyone. And fourth, as said in many cases, we need to bridge sectors. Although we measure water in hydrology, it's being used in all sectors and very important for health, for education, for businesses, etc., etc. So let's reach out hands to experts on the other side of the fence also. So with those words, I'd like to close this session. I'd like to thank the panelists, the speakers, for fantastic work. I'd like to thank UNESCO IHP, Abu Amani and Anil Mishra for providing us with the opportunity to be under the auspices of UNESCO to carry out this work. And thanks to the audience for being with us out there around the globe. Very well, thanks a lot and bye-bye.
Thank you.
Bye-bye.
Thank you.
Thank you a lot.
Bye-bye.
Mats.